All right, your quiz or your test tomorrow. All right, it's 8.1 to 8.6. There's 15 questions, but 14 of the 15 are coming from 8.5 and 8.6. So you'll just have one from the quiz. It'll either be a geometric or an arithmetic sum, and I'm going to give you the formulas again. So it's very, very, very minimal from the quiz. It's mostly this probability and fundamental counting principle stuff. Now, again, I showed you guys yesterday how to use the calculator for permutations, combinations. If you guys need a refresher today, I will help you with that, not tomorrow. So if you look at a question like this, it says, how many different batting orders can a baseball coach create from a team of 14 players? There's 9. Is this a permutation or a combination? Does order matter or not? Think about a batting lineup. Does everyone bat at the same time? No, there's somebody that has to go first, somebody has to go second, somebody has to go third, right? So if there's 9 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 14 people to choose from. So how many people could be the leadoff, could be the first batter? 14. Then how many are left to be the second batter? 13. Then what? 12, 11, 10, 9, 8, 7, 6. And then you multiply them together. Now, some of you might have said, well, I just knew it was a permutation because order mattered. So you would say there was 14 total. Use your permutation, and then there's 9 that are going in the batting order. So it's 14 factorial over 14 minus 9 factorial. You will get the same answer either way that you do this. But do you guys understand why order matters in this case? Because everyone has a different job. You cannot be the first batter and the second batter and the third batter. It's not that you're all on one, sitting on one committee doing the same thing. So your answer here, I got 726,485,760. You guys agree? For those of you that did it. If not, I'm not going to wait for you guys to do them all. All right, consider 8 sprinters are in a race. I want to know how many can finish first, second, and third. Does order matter in this one? Yeah, absolutely. So you have 8 people in the race. First, second, and third, how many places is that? 3. So this would be 8 factorial over 8 minus 3 factorial. 8 minus 3, and then factorial on the outside. Another way that you could look at that, guys, is if you said, okay, there's 8 places, right? 1, 2, 3, 4, 5, 6, 7, 8. What are the only ones I care about? First, second, and third. Well, if there's 8 people in the race, how many could possibly be first? 8. After that one person is first, how many could possibly be second? 7. After that, then you have 6. So if you multiply these together, you guys get 336. Does that make sense? All right, distinguishable permutations. The most places where you make a mistake with this, guys, is you don't count correctly. How many letters are listed here? This isn't a word, obviously, but how many letters are there? 7. Okay, so it's 7. The total number on top, 7 factorial. Then you divide out what repeats. So it's 2 factorial and then 3 factorial, right? Because L repeats twice and A repeats 3 times. So if we're going to work this out, you have 7 times 6 times 5 times 4 times 3. Why can I stop at 3 factorial? Because there's 1 on the bottom. So I can cross that out. Now you could just multiply 7 times 6 times 5 times 4 divided by 2. I go ahead and say, well, 2 goes into 2 once and 2 goes into 4 here. But when you multiply all of these numbers together, we get 420. You have to divide out the repeats. Same thing in a question like this. How many letters are there? Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah? So 10 factorial. Now, a lot of stuff repeats, and that's okay. I see P how many times? Okay, so 2 factorial. I see D how many times? 3 factorial. And I see E how many times? 4. All right? We don't multiply that together and say 2 times 3 is 6 times 4 is 24. It's not how that works. Write it out. 10 times 9 times 8 times 7 times 6 times 5 times. Why can I stop at 4 factorial? Because there's 1 on the bottom. I see that. And write the other ones. 2 times 1 times 3 times 2 times 1. Do you have to write the ones? No. Now, sometimes, guys, these numbers get really big, and if you try and put everything in your calculator at one time, it tells you overflow error, you get scientific notation. If that happens, then simplify within. Simplify the numerator, simplify the denominator. But you will not, I've worked out all the answer keys already. There's nothing in scientific notation, no crazy huge numbers, so just pay attention to that. I'm going to cross cancel and say 2 times 3 is 6. You guys agree? And then 2 goes into 8 4 times. So when I multiply all of this together, I got 12,600. 10 times 9 times 4 times 7 times 5. Check me. You guys agree? Okay, now we're going to talk about license plates. We talked about these problems, and the only way that these problems can change is if you say, like, a different amount of digits. Numbers can and cannot repeat if you put restrictions on things. In a certain state, an automobile license plate has 3 letters, so I'm going to put out 3 spaces, and I'm going to put an L underneath just to remind me that it's letters, followed by a 5-digit number. So 1, 2, 3, 4, 5. These are all digits. Now everybody, there's going to be all sorts of different forms. Somebody's digits might be 0 through 9. Somebody might be 5 through 9, whatever. You have to calculate how many digits they're talking about. Do they give me any restrictions about the digits? Do they tell you it's 0 through 9 or anything like that? They just tell you digits. How many digits do we know there are? 10. All right, so it says how many distinct license plates can be formed in the state. Does it say anything cannot repeat? Does it give us any sort of stipulations or exclusions? No. So how many letters do we have? 26. There's 26 times 26 times 26. How many digits? 10. So I just read a whole bunch of 10s here. The way that could be changed if it says the letters cannot repeat. So you'd start with 26, and then what would the next one be? 25, then 24. What if they say the last digit cannot be a 7? There's 9, okay? So just pay attention to that. Yeah.
What would be an example of like that you said if the digits were 5 through 9? So there'd be 5 digits? So
If you say they told you that the digits were 5 through 9, well, how would you figure out how many? You would say 9 minus 5 plus 1. Yep. So when you multiply this together, you get a ginormous number. I got 1,757,600,000. You guys agree? Okay. All right, good. Yeah, what's up?
You said something about like the last digit was like had to be like a 7.
I'm just saying, they give you the stipulation that the last digit cannot be a 3.
Okay.
So of the 10 digits, how many of them are a 3? 1, so then there'd only be 9 possibilities for that. Just read the restrictions. Like here, right? 5-digit zip code. 1, 2, 3, 4, 5. How many digits do we know there are, since they don't tell us otherwise? 10. Do they tell us anything about the digits? Can't repeat, can't do this, can't do that. No, so it's just 10 in each spot. 10, 10, 10, 10, and 10. Multiply that together and you get 100,000. So how could I change that question? Very easily. Look at this. Same thing. 5 digits in your zip code. It tells me something about which digit. The second one. This one is a 1 or a 9. So what are the possibilities for the first space? 10 different ones. What are the possibilities for the second space? Just 2. It can either be a 1 or a 9. That's it. And then the rest are 10. So you're going to have to read the wording. Tomorrow, you cannot raise your hand and be like, do they mean? That's the part of this test. Not multiplying 10 times 10. That part is easy. You guys have a calculator. It's understanding what the question is asking. That's where it can get a little confusing. All right, find the number of ATM codes. Now we're talking about a 4-digit number. So, okay, fine. 1, 2, 3, 4. Do they give you any restrictions at all? No, so what goes in each space? 10. 10 to the 4th power, right? So it's 10,000. Find the total number of ATM. If the 4th digit is not a 0, I always go like this. I say, okay, that's the digit we're talking about. It's not a 0. So there's 10 possible here. Excuse me, 10 here, 10 here. How many are possible in the last spot? Why is it only 9? Because it could be anything but a 0. 9,000. How do you guys feel? Okay? All right, when you come, thank you, it's fine. When you come to problems like 8, 9, 11, these are all the same kind of problems. You'll see these problems talking about like pizzas or talking about classes, choosing classes, a course schedule, talking about making a sandwich, stuff like that. They'll tell you the types of bread and the types of cheese and the types of meat. All you're doing is multiplying. They're telling you that a student is picking their classes. How many possible math classes are there? There's 4. How many science? 4. And 2 social studies? Social sciences? Whatever. All you do is multiply them together, guys. 4 times 4 is 16 times 2 is 32. And they give you a whole bunch of different options. It's just that it's the counting principle. You just multiply together. Customer can choose, okay, 4 different amplifiers, 9 different receivers, and 10 speakers. How many different combinations can you make? 360 with the different choices. You're not given a set and you're picking a certain number of that set. It's just, hey, here's all these different choices, multiply them together. Let's do 11. Same thing. We're talking about dissecting things, right? So there's 6 earthworms, 7 frogs, and 3 fetal pigs. That's awful. So I get a total of 126. I don't know why I wrote a 9. That make sense? All right, any type of questions that talk about a test. All right, you're thinking all of these test questions or questions about tests are all answered the exact same way. It says, how many different ways can a 14-question true-false exam be answered? What does it mean to assume that no questions are omitted? Tell me.
The student didn't skip a question.
You didn't skip any. All of them were answered. You just assume they're all answered. So there's 14 questions, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Independently, how could you answer the first question? 2 different ways, right? What about the second question? 2 different ways. What about the third question? 2. What's going to happen each time here, guys? You're just going to, what does this end up being? 2 to the what? 2 to the 14th power. If this was a multiple choice test and it had 5 answer choices, what would go in every single spot? 5. You just raise it to the power of however many questions there are. So 2 to the 14th power, excuse me, gives me 16,384 different ways. Yeah? All right, guys, deck of cards. I put the deck of cards in Module 8 the day we started this, Chapter 8. I told you guys it was there. I've referred to it a bunch of times. You need to know things about a deck of cards. There's 4 different suits. There's 26 black, 26 red. How many face cards? You guys need to know those things. And you need to understand the difference between an overlapping and a mutually exclusive event. Overlapping means a face card that's also black. A red that's also a 2, something like that. You have to be able to see that in your mind. That's very important, okay? So make sure you guys are looking at that. These marble questions, some of these got us yesterday. The biggest thing, honestly, the biggest thing you can do at first is to make sure that you add correctly. How many marbles, in number 12, how many marbles are we talking about? There's 6 total, okay? So write that down. There's 6 total. Give yourself every opportunity to get these questions right. What is important about this question? Without replacement. So what happens after I pull the first marble? What happens to the amount of marbles that are in the bag the second time? It decreases, okay? So this is asking for red. So it's saying I get a red the first time, red out of the total, times red out of the total. So think about it. How many are red? 3 out of 6, correct? So we reach in, we assume we got what we wanted. I have a red marble in my hand. I throw it as far as I can. How many red marbles are left? 2 out of how many? 5. So this becomes 6 out of 30. Anytime you have a fraction, what should you do to it? Simplify. If it doesn't tell you what to do and you have a fraction, just leave it as a fraction. If it says to give as a percentage or something like that, then, do what you need to. But if you have a fraction, guys, simplify it.
Why did you have like a 5 on the bottom?
Because it says without replacement. So that first marble that you pulled out, you did not put it back in the bag. So that's why. If you did replace it, then you would look at it, be, oh, so pretty, and then put it back. So it'd still be 3 out of 6.
So on the test, do you want us to simplify it?
Yes, always, yeah. All right, yeah.
If it was like with, like not like the opposite without replacement, like the 6 would stay the same.
Yep.
What about the numerator?
It would say the same because you looked at it, you put it back in, and then you put it back in. So it's still there. It'd be 3 out of 6, 3 out of 6. All right, what does this question mean? Neither marble is yellow. So it's not yellow, right? You want not yellow 2 times. Remember, probability is what you want over the total. So how many in this case, how many marbles are we talking about? How many? There's 10 total, all right? What's another thing that's important? Without replacement. So I'm going to say, okay, how many out of the 10 are not yellow? 7, okay. So I reach in the bag. I assume the marble I got was not yellow. I do not put it back. How many not yellow marbles are left? 6 out of how many? 9. So this becomes 42 over 90. If you guys leave it as 42 over 90, you're going to get points off. Simplify, especially the fact that you guys are using calculators. 6 goes into both of these, right? 7 over 15. They're going to say something on the test that says, assume aces are high. What does that mean? Where is that? Where is that on the scale in a deck of cards? Is it below a 2 or is it above a king? So if they ask you what's the probability of getting a 10 or higher, it's a 10, a jack, a king, a queen, and a what? An ace. Okay, so that's what they mean by aces are high. So what is the probability that the card that you pull is a face card? So I want a face, a happy face. Face over total. How many face cards are there? 12 out of how many total? 52. Simplify that. 3 over 13. 3 over 13. Simple, very simple. 15 says a black card. So a black over the total. Well, how many cards in a deck are black? 26 out of how many total? 52. What can I divide both of those by? 2? What do I get? Okay, by 1/2. Right, if I went by 2, I would get what? 13 over 26, and then I could go again by 13, so it just becomes 1/2. Simplify your fractions, guys. All right, you're going to have to read the wording. I am not helping you guys tomorrow with the wording, so pay attention to that. It says this card is numbered between the probability that you get something between a 2 or a 10. Write it out, what you want. I want a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, or a 10, right? Out of how many cards are there? 52. What piece of information am I missing? Is there only 1 2 in a deck? There's how many? 4. How many 3s are there? How many 4s are there? So what do I need to do to this, guys? I need to multiply that by 4. Not that I'm not multiplying 2 times 3 times, but how many cards are there that are between a 2 and a 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, right? So how many total cards are there in a deck of cards that are a 2 to a 10? There's 36. 36 out of how many? 52. Will that simplify? Yeah, divide by 4. What's 36 divided by 4? 9. What's 52 divided by 4? 13. That make sense? All right, all right. What about a question like this? This is a gimme question. Like, do not mess these questions up. You're given a table, right? You want younger than 22, so less than 22 over the total. How would you guys figure out what the total is? Add. What's 19 plus 17 plus 1 plus 2? It's 39. Now, how do I figure out how many are less than 22? Well, 18 to 19 is 19. Plus 20 to 21 is 17. What's 19 plus 17? 36 out of 39. Will that divide? Yep, 12 out of 13. Which should make sense, guys, if you look at that. The majority of the students in this chart are younger than 22. Yeah? All right, we're going to get to some more card stuff. Mutually exclusive versus overlapping. So think about this. I want a card that has a face on it, or, what does that word or mean? Add a black card. All right, well, how many face cards are there? 12 out of 52. How many black cards are there? 26 out of 52. Is this a mutually exclusive? Does one thing have nothing to do with the other, or is there an overlap? There's an overlap. How many cards have a face on them, but they're also black? Good, so minus 6 over 52. So 12 plus 26 minus 6 is what, 32 over 52? Divide by 4, you get 8 over 13. Agree? All right, probability of a heart or means what? A diamond. How many hearts are there in a deck? It's a suit. There's 4 suits. 13 out of 52. How many diamonds are in a deck? 13 out of 52. Are there any cards that have a heart and a diamond on them at the same time? No. So this is a mutually exclusive. Has nothing to do with it. One has nothing to do with the other. So 13 plus 13 is 26. What's 26 over 52? 1/2. Half the deck. Half the deck. All right, this is another one of those gimmies. This is a gimme problem. If it says to you 18 to 21, well, how many total people are in this chart? 30. How many are between the ages of 18 and 21? Well, what are you going to add? What 2 numbers? 14 and 12, which is 26. And then simplify. Divide by 2. 13 over 15. Yep. All right. You can answer 16 questions from a total of 20 questions on an exam. How many different ways can you select the questions? How is this different from the other test questions? Does it tell you how many answer choices each question has? No. Is this a permutation or a combination? Why is it a combination? I agree. Why? You can answer them in any order. Tomorrow when I give you your test, I don't care if you start with 1 and end with 14, 15. Or if you start with 7 and then go to 12, then it doesn't matter. So what you're looking at is you're saying, okay, there's 20 questions and you're going to choose to answer 16 of them. It does not matter the order. Yeah.
How do you know which one goes on the left and which one goes
The bigger number is always first. If you put it in your calculator backwards, it'll give you an error. So this is 20 factorial over 20 minus 16 factorial times 16 factorial. Now, somebody tried to do this in A period, and they said, I put that in my calculator, and I got an overflow error. Yeah, you absolutely would. Your calculators don't have enough screen space to show you that answer. That's why there is a formula built into your calculator. If you don't use that formula, you're going to have to say, okay, 20 times, or 20 factorial over 4 factorial, 16 factorial, and then 20 times 19 times 18 times 17 times, I'm going to stop at 16. You guys agree? This would cross out, and then you simplify. But if you're going to use your calculator, I need to see this. God bless you. I want you to understand, God bless you, which formula you're using. But your calculator will simplify this for you. And when it does, practice that. What do you guys get? 20, choose 16.
4, 8, 4, 5.
Yep, 4,845. Agreed. Good. How many ways, different ways, can a jury of people be randomly selected from 30? Think about this. 30 people are sitting in a room, and 12 of them are going to be picked for a jury. Does it matter if Sebastian is picked before Hannah? No, because they're both going to be doing what? The same job. If you are running for class president versus vice president, something like that, order matters then. If you are trying to get a specific role in the school play, order matters. But if you're just trying to be on the same team, or you're trying to, get everything in the same basket, that's just a combination. So this would be 30, choose 12. So you'd have 30 factorial over 30 minus 12 factorial times 12 factorial. Do the 30, choose 12 in your calculator. What do you guys get? Did you guys get 86,493,225? Yes. Now, it is a blessing that you don't have to write out 30 times 29 times 28 times 20 times, blah, 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 blah. You guys, so many of you made silly mistakes on your quizzes just because you crossed out numbers and then forgot to multiply, that sort of a thing. So if you have a calculator, you should educate yourself, know how to use it so you can simplify your life. All right, this last question here, not last on the thing, but last in this page. You guys had one like this on WebAssign. All right, it says law office interviews for 10 openings, 15 paralegals with 2 years, 22 with 1. Are they all doing the same job? Yeah. They're all doing the same job. We're all doing the same job. But there's just 2 different combinations you're doing. You have a combination here and a combination here. You have 2 sets. You have some people that have a certain amount of experience and some that have others. So you have 15 paralegals that have 2 years experience, and you want to choose 6 of them, correct? Then there's 22 paralegals, and you want to choose 4 of them. It's just 2 combination problems. When you work this out, this one here is 5,005 times this one here is 7,315. You're going to get a big number, and that's okay. 36,611,575. You absolutely will not get scientific notation on tomorrow's test. I've worked out every single answer key. There's no scientific notation. So if you get it, you did something wrong. Yes?
For these types of questions, can you write out the factorials as well as?
I'd like to see this. Like 15 factorial over 15 minus 6 times 22, just so I know that you know the formula. Because if I didn't teach you the little trick, you guys wouldn't know how to do it, right? You need to know the formula, so just humor me. All right, scooting along. These first 2 questions, there's not going to be one like this on your test. But I want you guys to understand, some of you understood how to answer this, and some of you were a little confused. It says, estimate the number of unemployed workers, the age group of 22 to 44. Round your answer. All right, you need to use a proportion here, guys. How many in this group are between 25 and 44? What's the percentage? They don't give you a number. If they gave you a number, you would just add the numbers together, put it over the total, and then divide. But they don't give you the number here. They give you the percentage. This is why this one's a little different from the notes. What's the percentage of that group? 39%, right? Out of 100%. So then you would say X, whatever that 39% is over the total, which is 11.46, and then cross multiply. If they gave you that this was, 365, and this was 920, whatever. If they gave you the actual numbers, you just add them together and then divide. But here they gave you the percentage. That was a little more difficult. Same thing on this one. Estimate the number of unemployed 25 or older. So what do you do with all the percentages here? You add them, 25 or older. So it's 39 plus 29 plus 3 over 100, and then equals x over 11.46, cross multiply. Now, these ones here, I know some people were having issues with the WebAssign. It says, what's the probability that a person at random from unemployment is in the 16 to 19 age group? Literally, guys, the 16 to 19 age group, it's just 12%. That's the probability. But some people put in 12%, it wouldn't take it. So then they tried 0.12, and WebAssign wouldn't take it. But then when they put in 12 over 100 and simplified, do you think WebAssign took it? Yes. For whatever reason, I don't know. But understand that all three of these things are the same. There's a question tomorrow that I specifically say, round to your nearest percent or whatever, so you guys know. Other than that, it's just keep it all in fractions. Because most of the probability is going to be, the marbles, the cards, that sort of thing. What's the probability here that the unemployed person is from 20 to 64? Well, how do you figure that out? Look at the chart. 20 to 64. What do? I'm going to add. So 17 plus 39 plus 29. 17 plus 39 plus 29. What is that, about 85% of your pie chart? What's the probability that 45 or older? 29 and 3. So 42%. This is from last year. Don't worry about this. We're not doing Pascal's right now. One question I do want to visit just to make sure. Some people had questions about this. Okay, what is this called? This is a sample space. All right, so it's what is the probability of getting exactly 2 tails? I'm not asking you to flip anything. Look, how many outcomes are there? 1, 2, 3, 4, 5, right? Of those 5, how many have exactly 2 tails? Not 2 or more or 2. How many have exactly 2 tails? So your probability there is 1 out of 5. What is the probability of at least 1 head? What does that mean? 1 or more. Okay, so out of the 5, how many have at least 1 head? 1, 2, 3, 4 of them, right? So 4 out of 5. Don't make a question like that harder than it is.
What if it says out of 3 flips?
No, I'm talking about actual, here is the sample space. If it says out of 3, then you'd have to write them down. You'd have to make your own sample space. But if they give you a sample space, they're telling you, here's how many outcomes there are. How many of these outcomes fall into the category that they said? Does that make sense? Okay. All right, guys, we are finito. You're ready.